Hi everybody. Seeing as BBB crashed on us, I decided to make this really quick video just to go over this worksheet that I was planning on going over during class. So I'm actually going to start from the beginning. Okay, just remember that my worksheet looks slightly different than yours. Okay, your worksheet actually doesn't have this section here. Okay, nonetheless, I'm going to start. I'm going to start at number 2 on my worksheet. Between which two letters is the rate of speed the fastest and why? So we can see here, if we just even look at the graph without making any calculations, we can see that between B and C, okay, the slope is the steepest. So we can see that because the slope is the steepest, and remember we said that the slope is equal to speed, okay, so we can actually tell just by looking at it that the speed is the greatest B and C. So between sections B and C, the slope is the greatest. Okay, so for number 2, speed is greatest between B and C because the slope is the steepest or the greatest. Okay, number 3, the least amount of distance covered occurred between which letters? So we can see the least amount of distance was between D and E, and at which point here between D and E there was no motion at all. Okay, so D and E covered the least amount of distance. So for number 3, our answer here is D, E. Okay, number 4, identify the type of motion occurring between letters C and D and give evidence for your support. Or sorry, give evidence to support your reasoning. So let's look at C and D together. Now C and D is something a little bit different than what we're used to. We've usually seen straight lines, okay? And straight lines usually mean, and I'm going to write this down here, straight lines usually mean constant velocity or constant speed, okay? And in this case here, I'm going to write straight line equals constant speed. Now in this section here between C and D, the line is actually curved. Okay, so what this is telling us is that the person is actually slowing down. So here, I'll actually do it in a different color so we don't get mixed up. So here between C and D, the person is slowing down. And how can we tell this? Again, not even by measuring anything or calculating anything. We can see that the line is steep, and then it kind of gradually, the slope of the line gradually decreases until it reaches 0. So we can tell here that there's deceleration, okay, or that the person is slowing down, the object is slowing down. Okay, so if we go back to our question, identify the type of motion occurring during C and D, well, the person is slowing down, or there's deceleration, and I'll write it here. Okay. During the total journey, how many total seconds pass when the object is not in motion? So how many seconds pass when the object is not in motion? Now again, going back to our graph, the person is not in motion between D and E, and that's approximately, if we look down here, it's approximately 5 seconds. Okay, so for this is number 5, it's 5 seconds. Okay, number 6, calculate the average speed between B and C. Average speed. Average speed is the total distance divided by the total amount of time. And we can do that by finding the slope. Now between B and C, the person went from 10, we can see it here, the person went from 10 to 40, okay? That's 30. They covered a distance of 30, so speed is equal to 30, and they did that in 5 seconds. So the speed is 6 meters per second. And I'll go back here just to show you. Between B and C, the person went from 10 to 40 meters. Okay, that's a distance of 30 meters, and they did that between 5 and 10 seconds. That's 5 seconds. So 30 divided by 5 is 6 meters per second. So that's our average speed between B and C. That was number 6. Let's go to number 7. How much distance did the object cover over the entire journey? So the distance covered, I'm going to write it on top here. So we can say 55, okay? So our distance covered is 55. Number 8, calculate the average speed over the entire journey. Okay, I'm going to go here for number 8. Well, the total distance is 55, divided by the total amount of time, which is approximately 24 seconds. So if we go back to the graph for a second, we can see here that it's approximately 24 seconds. Okay, so 55 divided by 24, and if I remember correctly from the answer key, it's 2.29 meters per second. Okay, so that's number 8. Now for number 9, it asks you to kind of tell a story of the graph and what was happening. I'm going to go back and read your stories. Okay, but here we can see that from A to B, the person is increasing speed because we see the slope of the line increasing. Between B and C, the person was at a constant speed for about 5 seconds, at which point they started to slow down between C and D until they stopped for 5 seconds. And then from E to F, they slowly, at a constant speed, reached the 55 meter mark. Okay? So if we go to the next page, speed is the greatest between, In the next page, you had to match the graph with the description. So if we look at these graphs, we could do the first one here. Okay, it says graph A matches description because. So graph A, if we look at it, okay, it's a distance time graph, and we can see that it matches description 5. So I'm going to write 5 here. Okay, and we can tell this because as time passes, now I'm not going to write these down, I'm just going to say them verbally. As time passes, the distance does not change. Okay, so for graph A, technical difficulties here. So graph A, actually I might as well write time passes, distance doesn't change. I probably won't be able to write them for all of them because it's just going to get really messy. For graph B, okay, the best description here is constant speed, high rate of speed. Okay, this is number 2. Now, why high rate of speed? Now, if we look at, for example, a comparison between B and F, we can easily say that it's constant speed and a low rate of speed. So the difference between these two, between B and F, is that in B, the speed is higher because the slope is greater. We can see that the line is steeper, covers more distance in less time. And for F, it covers a less distance in a greater amount of time. Okay, so we can tell those already. So I'm just going to put, for B, I'll put 2 here. Okay, and for F, we will put 3. Now let's look at these again. Letter C, now here, remember we said for letter C, just because the slope is decreasing doesn't mean it's slowing down. It simply means that it's moving backwards or moving back towards the reference point or the starting point. So this is number 6. Okay, so number 6 here, remember in a distance time graph, if we have a negative slope, it does not mean it's slowing down. It simply means that it's changing position or moving back towards the starting point or reference point. Now, if we look at D and E, these are newer graphs that we haven't really looked at. We haven't really looked at curves, but based on what we know, we can figure it out. For letter D, the slope here, now the slope is changing. Okay, now the slope here is not as steep, and then it suddenly gets steeper. So we can see that the person covers less distance in the beginning and all of a sudden covers a lot of distance in a shorter amount of time. So here we can say that there is an acceleration. So number 1, the person is speeding up. Now, on the contrary, for letter E, the slope is really steep here in the beginning, and then it kind of the slope decreases towards the end. So here we can see that the person is decelerating. So it's number 4. Okay, so again, these are the answers. I guess it's easier for you to see them here than for me to write them out. Okay, number 5, there's no motion because the line The distance does not change as time passes. Okay, for letter B, the difference between B and F, they're both constant speed, but in letter B, it's more distance covered in a shorter amount of time. So the speed is greater for letter B than for letter F. For letter E, this simply means that it's constant velocity. The line is straight, but the negative slope simply tells us that the person is moving back towards their reference point or their starting point. And letters D and E are showing us acceleration. D is showing us a positive acceleration where the person is speeding up, and E is showing us a negative acceleration where the person is slowing down. So that's it for this worksheet. Really, your homework is to complete these 4 graphs. What I want you to pay attention here is that these are time and speed graphs. So time will go on your x-axis, speed will go on your y-axis, okay? And you will plot the points as we did for the distance time graphs. Make sure you have a title, okay? Make sure all your axes are labeled properly, okay? And you will answer the questions that follow, okay? And there are 4 of these to do. So this is your homework for next class. Hope this was helpful.